Okay. Now pick it up. Okay, so anyway, hit the return key. That's going to activate that. Of course, anything that's brackets, it means it's optional. One of the things we need to understand is some commands will require arguments. Some do not have any arguments whatsoever. Some will have a variable amount of arguments. So you can kind of think of our tar command. It requires more than one argument for it to actually work right there. So it just depends on the command. And of course, most of those are separated with a single hyphen right there for those options. And then I think on this next slide, no, it's coming up, but there's actually another version. It's a dash, but we'll see that here in a second. You will see usage statements a lot of the times. So here's an example right here, and we'll be creating our own usage statements when we create scripts. They're just built into the actual command that we have. And it's just a short message to let the user know that, hey, they did something wrong. So in this case, we did make directory. Well, make directory requires some type of argument or it can't do anything. So it's just letting me know that, hey, you did it wrong. And if you want to learn how to do it right, then do dash help. And that'll get you a list, a short kind of condensed list of how you should actually use that command right there. So again, it should be built into most commands right there, and you will be creating your own later in the semester here. Also understand when we have these commands that the arguments that come after them are numbered, and make sure you pay attention to this, that the first command, when we always call it a command, it is actually given the position of argument 0. And then everything after it. So temp right here, it's the first argument. So it gets argument 1 and so on. And then we can reference those numbers and actually play with those. And we'll do that when we start writing scripts. We'll start using those numbers in our scripts to reference the arguments that we're giving to the actual script. Right here, further expanding on the options, and really all you need to kind of know from here is we have these single character options. That's kind of what we've been using, but there are long versions of here, and that's you give a double dash and then a full actual name that goes on that. So when should you actually use this? I like to use it when I'm writing a script and I'm writing something, or maybe an option that I've never used, or a command that I've never used, and I definitely don't know the options, and it's really, really vague. In other words, AL, if you didn't use the ls command, it would be hard to know what AL meant, but here it's spelled out, it's all. So you're going to see those hidden files. You got the format, which equals verbose. So you can kind of go back, and you're not going to have to comment as such because your code is telling you exactly what it's doing. So good time to use those, but most of the time people are going to use the shorthand version when it comes to the terminal. Talking about processes here, what was I pointing out here? Oh yeah, so so far we're doing things that are super fast, so we don't actually see this taking place. But I want you to understand when we initiate a command, execute it, that is called the foreground. So it is taking up the foreground. While that command is running, we can do nothing else in that particular shell. Now we could spawn other shells and work in them on the same system, that's fine. But this is going to an inactive sleep state. So in other words, it's taking up. So if we ran a process that took 5 minutes, then for 5 minutes, that shell would just kind of be frozen, sitting there. And it just depends if it would sit there doing nothing or give us some type of output. Like the ping command, if you're pinging a server, that is taking up the foreground. Of course, you're constantly getting output, but if you sit there and type, it'll actually type stuff on the screen, but when you hit enter, it's not going to do anything. It's just gibberish that you're just putting on the screen. That's meaningless because it's still running that process. So just note that you can't run 2 things at the same exact time by default. We'll figure out ways to work around that later. All right, standard input and standard output. We've been working with this all semester long so far. So this is just kind of explaining it a little bit more in detail. So we have standard out, and by default, that's just going to go to the screen. We have standard in. By default, that is our keyboard. Now, again, these are defaults. We can manipulate that. We're going to see that in a second. Standard error, this is a channel that's been running all this time and we don't even know it. So in that example of make directory, when I ran that and I hit enter, that was actually standard error that was sent to that screen because that was an error that took place. The program did not work as intended because you didn't have the argument to that. So that is actually a separate channel, but sent to the same place, to our screen there. Understand again that everything in Linux is a flat file. I kind of showed you how the directory, it was a flat file. Your printer, if we don't have a printer installed right here, but if you did, it would be in /dev/LPR. We could actually, we'll talk about redirection here in a second, but we could redirect files into LPR right there, and then it would print for us. So your modem, of course, we don't hardly have those anymore, but your modem would be, and the TTY, this is just the terminal that we're in. So there's going to be several of these like TTYs that are on our system, and they'll have a number associated, but that's just the terminal that we're in. All right, so here's kind of a visual representation of what's going on with those standard in, standard out. They're called file descriptors. I think we'll see that term here in a second, but you can kind of see the computer right here. So that's where we're on. So if we send standard in, that is on channel 0. So it goes into that channel, and then the command ls is going to be run, and ls is going to send things to 1 or to 2, depending if there's an error. Of course, more than likely there wouldn't be an error, so we'd just send it back on channel 1, which would be standard out. But we can manipulate that here. We can actually say, okay, I'm going to send standard error, or sorry, standard in, and then the standard out, I'm going to change that default action, and instead of sending the standard out to, instead of sending it standard out, I want it to go to foo.out. And if there's an error that occurs, I want it to go to foo.error right here. So we're just redirecting those channels to do something different than their default. So make sure you note the spelling of these. This helps me out when it comes to grading. So I don't want it spelled out as standard space in. The correct way is STD in. So that is standard in. That is on channel 0. Standard out is channel 1. Standard error is channel 2. All right, so redirecting. We've seen this right here. Let me see if I can get my pen. I think we've seen these two so far. Seen these two so far right here, and that is that right arrow. So both of those are standard out, but the single arrow, you can see if the file exists, it'll just overwrite the contents of that file. If it doesn't exist, it's going to create. Versus the double arrow is just a pin. So if the file does exist, then it's just going to add to that file. And then if it doesn't exist, it's just going to create it. We'll be using these right here a lot later in the semester. And it's very important that you understand the difference of these. Of course, we'll talk and kind of show the ups and downs, the problems it can cause if you don't use them correctly. And then we just got standard in. So that's that left arrow right there. We have been doing standard in all the time. Anytime we actually give an argument to a command, that's standard in. But we can actually explicitly, and there will be some commands that we'll see later on where we want to use this arrow because it slightly changes kind of the behavior of the command. But we could take, instead of typing on the keyboard, we could take a file that we've already got some data in, and then we could redirect that file into a command. So that's why we would want that standard in operator right there. And then we've got these two right here. So that is our error channel right there. So understand that this right here is a 1. That's a 1. This is a 0. It's just there's no other options with it. So you can specify 1 right arrow and it'll work. Or since there's no other channel, we don't have to worry about it right there. It's going to, in other words, now there's no other channel. It's going to default to 1. We can just not put the 1 there. But don't get confused. You'll see it both ways. So this one, since we're not wanting it to do the default of standard out, we want it to do the standard error. So we're just redirecting the error right here. And the same rules apply. Single, you overwrite. Double, it's going to append right there. So let's take a quick look at this. So I actually don't have notes on this right here, so I'll just make it up as we go. So let's do echo, and we'll just echo hi there. And so if I hit enter right there, standard out by default, it's just going to go to our screen. Let's see. Now, if I wanted to redirect that, we could use the redirection arrow,
and we can just redirect it to, we'll just call it file1.temp. Someone's trying to call me. So now if I cat out file1.temp, you can see I have hi there. Now, if I wanted to go back here and let's just say hi there, and we'll do a 1 just for something different. Then you can see if I cat that out, I overrode it. So now it's 1 versus if I went over here and changed the arrow to that, and then we put maybe 2. And then again, we'll cat out that same file. Now you can see it appended there. Now let's see if we were to cat dog, which dog doesn't exist in my directory right here. So that is actually happening on the error channel. We can prove that by running that same command again, and then we can say to redirect it, and then we'll just call this error.log. So now if we cat out error.log, you can see same thing happens. So if I appended it, we would just get a whole bunch of them going on there. And then if, let's see, we'll use error.log here. I could say cat and redirect error.log into cat, and we get the same thing. It's the same thing as just saying cat error.log right there. It's just, I explicitly say redirect it. What you got?
All of the new line.
Yes. Yes, you're talking about it. Yeah, if I just run that double right arrow, yeah, it's going to append to a new line over and over and over there. So let's see. We did this right here, and I just sit there, do that, and then cat error.log. You can see each time new line, new line, new line. Great question. All right. Dev null. Dev null is a actual directory that's on all our machine. It's referred to as the bit bucket or the black hole. And everything that you send to it, it will just go to it and immediately deletes it. We can't even actually go in and see it like happen because it just instantly happens. As fast as it runs the command and it gets there, it just deletes it. You're like, what good is that? We'll see later on where it's good, but understand that there are some times that you may get error message. You may have a program that complains a lot of time and you just don't care about that. You could actually send it to dev null, and then dev null just deletes all that for you. But when it comes to coding scripts near the end of the semester, we're actually going to show you a really cool use. And you will see that a lot of programmers do use it because there are times when your scripts are going to generate some information that you don't want your user of the script to be, kind of interfere with their the flow of that script right there. They don't need to know that it's happening in the background, so let's not bother them with it.
And it's always fun to run this. So let's see, we have that same cat dog error right here. So, if I ran that, doesn't have it, I could then go ahead and say redirect it to dev/null, hit enter. There it is. If we were to cat.
Yeah.
Oh, damn. Thank you. And then, oh, it's the actual, I'll just clear my screen. Okay. Good. Now you can see it. So we got that. And then if I wanted to, hang on, there it is. If I run the same command, now I've sent it to dev/null. And then if we were to ls dev/null here, it's just this file, which is not important right here, but just understand this is just the directory that it sends it to, and then it just goes away. It's kind of a funny directory. Okay. All right. Switching gears, path and expansion. I've used wildcards a couple of times. I think we've only used the asterisk, probably the only one you've seen. But these are the wildcard characters, and there are 3 different ones. There's the star, asterisk, the question mark, or the bracket, and they each are kind of slightly different. We can use them on the command line in scripts. I use them all the time. You can also use them in regular expressions, but when we hit regular expressions, they're not apples for apples. They are slightly different. It's just ever so slightly different, but actually a huge impact in the way that you use them. So if we take a look here at the star, it represents 0 characters. all single characters or anything. So basically it can represent nothing all the way to infinity as far as the characters are concerned here. And I like to play around with this one. All right, so let's set up a path here. Let's see, I'm going to CD into sandbox. We'll do ls. Okay, that's good. So I'm going to create some files real fast. So I'm going to do make directory, and I'm going to just create a test directory, and why can't, however, I got it, so don't need it. Now let's touch file, and then I'm going to touch file.bak, and then we'll do a .tmp. And then I'm going to do the cart before the horse thing and show you a nifty little trick real fast that we'll cover later. Curly brace, 1 ... and we'll do to 5 here, and then .tmp. So that's going to create file 1 .tmp, file 2, and so on for me. And then we'll create one more, and I'm going to do movies dot, we'll do BAK. Now I'll list them all right there, so you should be able to see them. All right. So we're good. Now, if I wanted to use the wildcard there, so if we do ls star.tmp, you can see I get every single file now that has that .tmp extension. And don't ask me why the funky color code, because I don't really know. Let me actually see. Are y'all getting that color code on your files right there?
Yeah, but whenever I make
Empty? That's what I'm wondering. That's a new update. It's never done that to me before. Well, that's pretty cool. So I guess a color cue that the file has no contents. Of course, this one right here, though, I don't know. I'm lost on that one. I've never had that one happen before. All right, now we can do ls file star. And of course, now we actually get file included with that. And then if we did ls star.bak, then we're just going to get the ones in the .bak there. All right, so question mark is just going to represent one character, and that's it. So kind of not, it's nowhere near the powerful as what the asterisk is there. So if you put 2 of them, then it's going to be 2 characters. 3 of them, it's going to be 3 characters right there. So if we wanted to get every single file in here that had like a 3 character extension, we could say ls, and we could do star question. Oh, no, it'd be dot, sorry. And y'all can't see that, can you? You can a little bit. Let me run it again up here. So if I do star dot question, then you can see we get everything that ends with a .bak right there. So pretty useful. Let's see. We'll cover the last one. So this is characters. We enclose a bunch of characters inside the brackets here. You can give it a range using a hyphen. So if you want to do like A through Z, that would work. But don't get confused, because this is still one single character. Think of it as an or. So in this case right here, it's going to be representing X or Y or Z. Real quick example with it. We can do ls, and we'll just give anything that starts with F or M, and then we'll just give a star right there. So you can see it picks up everything that started with F or M. If we expanded on it, and let's say we'll do .bak here. So then it's going to get file.bak, movies.bak there. Here's some examples that y'all can play with, and I even gave you that kind of what I did right there using to create those files if you want it, but we'll see that later on in the semester. All right, switching gears again, the translate command. This is going to be one of those commands that you kind of learn early. It's a very powerful command. Don't forget it, because it can really help you with like your project near the end. You kind of go with a gap where you don't need it in the class, so just don't forget it. So we have the command, our options, and then at its default value, the way it's going to do is you're giving it a search pattern right here. So I'm saying I'm searching for this string. If I find that string, I'm going to replace it with this string. So it's kind of like a search and replace substitution. So, but we can expand on that with some options. So this is just, again, that first example right here. It's the default. What it does is translation. But then if we give an option right here, this is the option of delete. So then you give it a string and there is no other argument because it's just going to look for this string and then it's going to delete that string out of the text. This one right here, I like to think of it as shrinking. So if you had like I in a word or double I, whatever, it just has to occur in a sequence right there. And if you gave it I as its argument right here, then it would search for that. And anytime there's a sequence of it, it would shrink it down to 1, no matter how many times it occurred. Now, this is the important thing to remember with translate. And that is when we give it these multiple options right here, what it is saying is I want to delete. So the first option goes with the first string. The second option goes with the second string. So in this case, we're deleting that first string and then we're kind of, I don't know what the word for that is. We're shrinking it down to a single occurrence of a letter in the second option. All right, so here's some examples, make it a little bit easier to understand. So in this one, I'm using echo here, A, B, C, D, E, F, and then I'm piping it to translate. And then when translate runs, I'm giving it a search string of ABC and replace string of XYZ. So you can see when we run it, it's going to replace that ABC right here with the XYZ. So one thing to note is there are very few of them, but there are some commands that technically don't work on their own. So translate does not have like an argument of this original string right here. It requires that you either like have an echo and then pipe the contents to TR, or if we saw the redirection operator. So if you had a file that you wanted to redirect and send to TR, then you could simply, like, let's just pretend this isn't here and we had TR, and let's say we had a file that had these contents, and we would redirect the file like this to TR right there. So that's another way of doing it. And then of course here we're giving a range A through C, X, and X through Z. So it's going to do the same thing. Here we're using the delete, and then we're giving, this is our argument. So it's going to search for all the vowels, and it just goes through and just deletes all the vowels out of the sentence. Here we're using that kind of suppression right here. It's searching for any occurrence of S, P, and I. So we can see we got Mississippi misspelled right there, but the double S's, double P's, and then the triple I's right there, they're all shrunk down to just a single occurrence of it. And then in this example, of course, the D belongs to the M, so it's going to delete the M and then do that suppression of S, P, and I there. Okay, so we've got these character classes, often sometimes called the list operators, and they're just kind of shorthand. We're going to see the other utilities that will use this throughout the semester. I would say the most useful out of this is going to be your alpha num, your alpha, the blank and space. Pay attention right here. So blank just does horizontal white space, while the space does horizontal and vertical. So it's all white space there. Of course, then we have a digit. So it's just all the digits. And then these two are really powerful right here, the upper and lower. So if you use that and translate, so you could search for all lower characters in a string and then just change them to uppercase. So I would say that's probably the ones you would use the most out of that list. All right, the complement, that can be confusing, but it's pretty simple. Just think the reverse. So anything you type, it's going to reverse of what you type. So in this case right here, we have ABC 1, 2, 3, and then I'm telling it to delete the digits, but then do the reverse of that. So what would it delete then? The letters. Perfect. And so it's going to leave the digits is the way you can kind of think of that. Here. Yeah, these are just examples right there. So here is that example where we're doing high there, upper, or looking for the lower characters, change it to the upper characters, and then it's going to give us that output right there. All right, so here's something that I want you all to figure out. and then we'll work through it. So can you write a command to eliminate the dashes from this phone number? Somebody tell me when you got it.
Complement of addition, like good one.
Try it out and see. So you'd start it with echo and then put the phone number in quotes, type it to TR, and then go from there. So we're struggling just on the getting started part. Anybody got anything yet? What you got?
So you would do echo the phone number. And then you could pipe it to TR,
Perfect.
and then you would use the dash D option to delete, and then you press delete on the dash, right?
There. Perfect. You did exactly the way I did it. There's other ways of doing it. All right, let's do another one. Can you write a command that eliminates all digits from the string? My social security number is no. Somebody has it? Let me know. All right, what you got?
DR.
Okay. Perfect. All right, last one. Can you use the complement option to write a command that eliminates all the characters from this string except the digits? So same problem. Just switched. I got anything? What you got?
Just adding a C in front of the B.
Perfect. You just did the complement of it. So it just did the reverse right there, and it didn't delete the digits. It deleted all of the text right there. Good job. All right, we've hit pipes. Again, I don't want y'all to forget about pipes. This is just kind of a reminder right here. It plays into this next thing right here, and that is T command. So T kind of goes with the pipes. So right here, I have an LS, so I want to list all the contents of the directory right here. But in this case, I don't want it just go to standard out, but I want to save that, but I also still want to see it. It's one of the things that I can't do with the redirection. I have to choose between. If I do LS by itself, it goes to standard out. If I did LS and a redirection operator, the right arrow, and I specify maybe file one, then it's going to save it to file one. But if I use the pipe and send it to this T command, then I can specify as many files. I can specify one, but as many files as I want. And it's going to create exact copies of what LS outputs, but it's also going to give me the standard out as well. So let's just show you that. So if we did LS, again, that would be the file. So if I did LS and then piped it to T here, then we could do file. Actually, we'll just use the files that we have, file dot temp, and then we'll use file. We'll just do 2.temp and hit enter. I get my output, and then if I cat out the file.temp and then file2.temp, you can see it kind of glued them together right there, but that is exact copies of it right there. Side note, since I did do this right here, the cat command, it is concatenation. So its true purpose is to kind of glue files together right there. But if you just give it a single argument, then there's nothing to glue together, but that's how we use to see the files. What you got?
I think it was mentioned earlier, can you use the translate command on files? So if you have like a folder of multiple files with specific type, to translate their essentially.
Yeah, I mean, yes, you could redirect. Yeah, you would redirect the file into it. I kind of talked about that example. How if you had a file contents, you could redirect the file into it.
Not the contents, the name.
The actual name of the file?
If you needed to rename a lot of files.
I think there'd be a way to manipulate it. I'll have to get back to you on that because you could actually use some bash script and then just call up those names, rename it, and then integrate it with a move command. But by default, no. I mean, it's not, but there's a lot of things we'll see later on when we get in here. You can kind of manipulate it to make it do different things than what it's kind of set up by default. But I can't think of a way off the top of my head right now to use that for that purpose. Okay, kind of going with pipes. I just wanted to show you this, and I don't have this written down anywhere. I'll just walk through it right here. So in this example, so we have the cat command. And then I am taking etsy/group. So that's just a list of groups. It's just a file that exists on our system. That's not important right here. And then I'm redirecting it, the output of that, and I'm saving it to a temporary file called group right here. Now, this is not in alphabetical order whatsoever. So I'm wanting it in alphabetical order. So I'm going to call sort right here. And then I'm actually just using the redirection operator because I can. So I'm using that group.tmp as the input. So it's going to send that data to sort. And then what sort outputs, instead of sending it to standard out, I'm going to use the redirection operator here to capture that to group1.temp. And then, so now that's going to be saved. So I have all of the groups and it's actually sorted right there. Then I'm going to use the grep command here, and I'm going to input my username. Understand this is a placeholder, so it should just be your username within single quotes right there. So I would put grep, quote J Corcoran, end quote. And then I would use group1.temp on that. So this is my input file right here that I'm running the grep on, and then it will then output to group.to. Is that confusing? Y'all want me to work through it? I can work through that. That's no problem. I should have done it to begin with. All right, so let's clear the screen and we'll just go ahead and cat etsy/group. So you can see here's all the groups on the system right there. So I'll clear that. Now I'm wanting to capture this one. So I'm going to say, okay, just send it to group.tmp. So now if I'll use the head command so it doesn't take up so much room here. So now you can see I captured some of that data. That's just the first 10 lines of it. Now I want to actually sort that. So I would say sort group.temp, and then we'll just call it group2.tmp. And I need to use the redirection operator, so I'll capture it. So now if I was to use the head command on group2.tmp, you can see that it's actually changed right here. It's actually starting with the underscore first, and then it's doing alphabetical from that. And now I want to find all of the groups that I am actually a member of here. So the way I'll do that is I will use grep, and I will say J Corcoran. And then again, we'll feed it the file right here of group2.temp. Now, if I run it here, we'll be able to see that here says the output. Of course, is it saved anywhere? No. So I need to go ahead and let's redirect it, and we'll just call it group3.tmp right here. Now, if I cat it out, group3, you can see I have that file. Lots of steps, right? What I'm trying to show you here is with the pipe commands, we can shorten that a lot right here. So we could say cat/etsy/group. Now we have that. Let's pipe that to sort, and then let's pipe that to grep, and then let's go ahead and put my name in there, and then redirect that to, we'll just call it group4.tmp here. All right, then if we cat out group4, you can see I've got the same exact output, only this one required 3 files to actually make it happen, and this one just required 1 file to make it happen because I kept on piping that instead. So it's like a perfect example where a pipe would be a good option instead of creating all these temporary files for such small things. All right, pipeline list. This right here, we call this a command separator. And that is if you just want to type out multiple different commands on the same command line. So if I wanted to cat, two different files. I could say cat file 1, then I could put the semicolon there and then do cat file 2. And it's basically saying hit enter for me in between these two right here. So kind of useful every once in a while. Some people like when you're creating a whole bunch of variables on in your scripts that you may want to put them out in one single line. Background task, we'll come to that a little bit later, but I wanted to kind of show that to you because of the fact that Boolean and is just the double version of that. So you've got 2 ampersands right there, and then 2 pipe symbols for our or. So in this case, you can think of all these programs, again, they're just pipelines. So if pipeline 1 is successful, the Boolean and would trigger and it would run pipeline 2 there. So in this case, we did make directory called new directory. If new directory was successful in its creation, then we could CD into it in kind of one line right there. And in this case, I'm running a grep and I'm grepping for Joe Bob in file 1. Now, if the grep runs successful right here, then, nothing happens. We will just get Joe Bob, every line that Joe Bob is in will be returned. But if Joe Bob is not in the file, then we use this or, so we can say the echo failed right here. And this is kind of useful in some of these commands because like the grep, it will actually, if it doesn't find it, then it actually returns nothing, which is kind of odd in the fact that most commands, when they run an error, they will return like some type of error message. Well, grep's kind of a little bit different. It'll only return something when it finds something, and when it doesn't find something, it just gives you nothing. So this is kind of creating a little custom error message if it finds nothing there. And then we'll talk about this later on right here. This returns the status code. And I didn't realize I had that in there this early, but the status code 0 is successful, 1 is unsuccessful if y'all run that. So if the grep command fails here, then if you echo $question, it should return a 1, letting you know that it failed. But we'll use error code or exit and error codes later in the class, especially when we start our scripts again. All right, so that's kind of covering all the random stuff up. Now we're hitting our Linux editor. Making good time. So when I started this class, we actually used all 3 of these editors right here, or I should say you had a choice to use all 3 of the editors. What happened was the majority of the class chose this one because it's the easiest. Then I would have kind of all of the power users that would try to use Emacs, and then a handful of people that use Vim. And then about a quarter through the semester, all of my Emacs people would just get really angry, and then they would move over here. Or they would get so angry, they would just move to here and simplify things. But my majority of the class took the Nano. So Nano is, it's kind of a dumbed down version. It's not very powerful. And so I've decided that I'm going to do away with this because one, I had never had a single semester where anyone survived the Emacs, so threw it out. Then if I did that, most people are going to choose Nano, and Nano is so easy, and it's also, you can't expand it like you can Vim. So we're going to go with the in-between right here. We're going to learn Vim. Good thing about that, Vim was the default across the board, but it's still installed on every distribution that I know. Because Linux is becoming so popular, and people would, you have non-power user, non-technical people, I should say, that tried to use it. They would get stuck not being able to edit a single file using Vim. So a lot of your mainstream distributions like Ubuntu has now switched to Nano as the default editor. But again, Vim is still on there, and it's way more powerful, highly configurable. You can basically make this thing however you want. Now, it takes a whole lot of work. It's up to you to do all the work. But a lot of people that use Vim, I've seen a lot of people say that they like it better than any IDE that they've tried out there because it is so configurable. They can make it just like they want. Let's see here. So this right here is one of my favorite quotes. It's by I Am Developer. It says, I've been using Vim for about 2 years now, mostly because I can't figure out how to exit it. And for anybody that's used Vim, that's pretty funny. For those of you that haven't, you'll find out why it's kind of funny here in a minute. And I was actually probably like one of these victims here. The first time I tried to use Vim, it was a nightmare. So VI is the original. Now we have Vim, of course, then we have that lovely Linux humor that came out with Vim, was just VI improved right there. On all your systems, if you were to try to use VI, it would actually be alias to Vim. So you're not going to have VI on there, but you could still use VI and it will pull up the Vim editor there. This right here, you more than likely, you're not going to open VI just by itself. But this is about the only information that you get from VI if you actually gave no argument. Of course, 9 times out of 10, you're going to give it an argument of a file that you want to create. So you can see that you have :Q is quit, then you have :help to get some help on there. But that's about all that you're going to get from Vim. Right here, I encourage each one of you to kind of do this just to make sure that you all have Vim on your system. Let me bring it up here. So if we do which Vim, it should pull up a path right there. And then you can do Vim -- version. And then if you scroll up to the top there, you kind of should see that you get the Vim VI improved. This one's running 9.1. I think I have 8.1 running in my office because I haven't updated right there, but you should have something near that. You should not come back with TinyVim. If you have TinyVim on your system, you need to install Vim. So has anybody got any issues? Good deal. TinyVim will drive you up the wall because it is very, very, small version, and not even the key combinations and stuff that we're going to be seeing. They're slightly different in there, and that will kind of drive you insane if you're used to Vim. All right, so here we can actually practice creating our first file. So I'm going to move over to here. So to do that, we can use Vim or VI, and then all you have to do is then specify a file name. We'll use practice.txt. So once you have that, you can hit enter. Now, in here, you can kind of see these little squiggly lines right there. That actually represents a blank line, meaning nothingness is there. And then we have that cursor. Now, I should have warned you beforehand, don't touch your keyboard, because if you do, you're in what is called a command mode, and every single key on your keyboard is a command and not actually typing. So if you want to type, you need to know the right command. There are multiple ones, but we'll start with I. If you hit I, kind of pay attention down here. When I hit I, it changes to insert. Once you are in insert, you are free to type. It is now like a normal text editor, sir. So I can just say this is a text file here. And now I can hit enter, and you can kind of see, we'll go back down. If I backspace that, there's not a line that doesn't exist, because those will show up in your scripts if you were to do that kind of stuff. Now, in order to save it, we have to get out of this command mode. So you would hit escape on your keyboard, and kind of note down here where it says insert, I'm going to hit the escape, and now that went away. So now I'm back in command mode here. Now, in order to save it, there are multiple ways. We'll use a shortcut first. That is going to be Shift-ZZ. Now, before you hit it, be careful. Don't hit Control-ZZ. That puts a program into the background, and then your whole file goes away. When you try to open it up, it says the file already exists. It gives you a headache. We'll see that later on. Just try not to do it right now, because I don't want to get into all the background stuff on here. So carefully hit Shift-CZ, and it should just go away. Now, if we do ls, we should see practice.txt. Of course, we can cat practice.txt out. We can open it back up with Vim, and then hit Shift-CZ and close it back down again. Okay, so that was our first file that we created there. Now let's actually look at a lot more of the details of it. So again, command mode, that's how you're going to be opening up at the very, very beginning. And then we have input or insert mode there, and that's how you actually type. Of course, you're going to hit escape to get out of insert mode. You can only save the file once you're in command mode. Now, the colon is actually going to bring up kind of a little menu that you can type in. Actually, it's more like a little command prompt within the editor at the very, very bottom. And that's where you can enter a lot of commands to configure it. So just note, colon gets that up. If you were to type help after it, it would get you the help menu. You could search for a specific keyword to get help. H, J, K, and L And also note that, again, this is in command mode right here. The H, J, K, and L are the arrow keys. You can navigate. Your arrow keys still work, but they try to be as lazy as possible and not move your hand. So they integrated H, J, K, and L. I really wish they would have done WASD. I would have been very, very good at it. I'm not good at the H, J, K, L. And if you want some status information, which I never use it, you can do the F there. Also note that in the directory for today, there is like a cheat sheet of all these commands that we're going over. So while they're in here, the cheat sheet's going to be way better for you. So while you're in command mode, X will delete a single character, DW deletes a word, DD deletes the entire line. I tend to use that more than anything. Then you got Shift delete, which wherever you're at to the end of the line, U will undo. And then note that these are all single letter commands, or actually not single letter, but they're commands on the keyboard. There is no shortcut for redo. You actually have to go into like the command line and then type the word redo. I don't know why they didn't put in a shortcut for it. Now, these are all the insert modes when you're in command. So you can see I and A, they're very similar. It's just where your cursor's at, it'll either be before or after your or where your cursor's at. And then the major difference would be O here. So if you want to actually have a new line and start typing on it, then you can do the lowercase o, or if you do an uppercase O, it's going to put a line above that one. So of course you could also just do I and then hit enter and get a line as well, but you know, lots of shortcut options there. R is going to actually give you a prompt to replace. So if you're just over a single character and you type R, then whatever character you type next will just replace that character in there. So it's kind of just a way to make a quick edit. Then you got colon, and then you give it a line number. It'll take you to that line number. Shift G will jump you down to the bottom of the document. And these right here are actually more like configuration options. It's many configurations. I'm just giving you a short list here. So if you did set space number, then you would have line numbers on the side of the screen when you're in your text document right there. Of course, if you don't want them, then you can do set no number there. Now, this is all when you're trying to save the file right here. So if you open up the kind of the command line prompt there, and then you type W, that's going to write the file. So it's going to save your file. And then if you want to give it a different file name, you could do the W and then space and then give it a file name. And then it's just going to save it to some other file name. If you have any trouble with saying that it's kind of locked, sometimes you can do the exclamation point and it'll try to force that overwrite. But if it's a file that root owns and you just don't have access to it, then you're out of luck. It's just not going to do it. Then, of course, we have append. Same thing right there. You're just going to pin to an existing file. Q is going to quit you out of it. Now, make special note here that if you're editing a file and you realize like, oh crap, I'm editing the wrong file, or I don't want to save this. If you try to exit out of that file using Q, it's going to tell you, hey, there's changes that haven't been saved. I can't exit. So you can simply do Q and then exclamation point, and then it'll force it, and then nothing is saved. Then of course, we have kind of our shortcuts right here with the Shift ZZ, that's quit and save. You can do X, that is the same, or you can kind of explicitly use the W and the Q combination there, then it will write and then quit. No, you can't do QW because then it quits first and then the write doesn't happen there. So make sure you get the correct order. All right. Learning curve. I love this graph right here. So this is kind of some of the common editors out there and telling you how difficult they are to learn. Of course, Notepad right here starts out a little bit, but then once you get the gist of it, it pretty much stays that way. The Pico editor actually starts out simpler, but then you start to realize it can do a little bit more. It gets a little bit more complicated, then kind of levels off. Then Visual Studio, it's kind of a mountain to climb. I'm sure most of you have used that, but once you get used to it, you like it. And then it actually becomes super easy, kind of like second nature to work, very intuitive. And then we got VI, starts hard, stays hard. And then you got Emacs right here, and it just breaks all the rules. And so Emacs does not follow the Linux philosophy of kind of do one thing and do one thing well. Emacs does pretty much everything. You can browse directories, you can configure all your files in it. Some people will literally configure their systems to almost in a way, bypass Linux and they just boot their system straight to Emacs and they do everything in Linux within Emacs, kind of ignoring the Linux commands. So there you will find very hardcore Emacs people online, because if you dedicate yourself enough to learn Emacs, then you're going to be very hardcore towards Emacs. But I am not that person. I don't want to spend all that time. And just to kind of show you just a little difference as to how to edit files. So you saw to edit a file in Vim, you just type Vim in the name. Here it's Emacs-NW-Q and then the file name. That's just what you have to do just to even start to edit a file within it. Nano, this is why people like Nano. It's very simple, and the fact that it actually explains something at the bottom, that's a whole bunch of just shortcuts. So it tells you how to save a file, how to quit, and, you know, just gives you a little bit more information, unlike Vim, which doesn't give you anything. But note how different it is. Control-0 is how you write a file to disk there, versus the way we do it. All right, there was something I forgot to take out right there, just kind of a breakdown of editing files and stuff in those. All right, we got a couple other things to take care of out of this. Let me put this to duplicate. Go. All right, so the first thing is I'm going to show you quickly, and this is going to be a part of your homework, is how to actually configure Vim and change it up a little bit. And you're going to want to do this, especially when it comes to scripting. One, you have no line numbers by default. Two, the color code on scripts when it comes to comments is atrocious. So I will give you a color code that works really good, a very vibrant color in there. So let's see, let me find my file in here. I think I put it in Sandbox. Let me CD in there. I moved it to the wrong place. No, it's not there unless it's a hidden file, ls-a. There it is. Well, let me move this thing .rc, and then we'll just move it back a directory. All right, so now let's go ahead. Okay, I'm going to extract that thing, I believe. So let me take a look at it again. It's a bzip2 file. So all I have to do is do bunzip to here on .vim rc, run that. Now ls-al, and now I just need to rename that, but I'm not going to rename it right now. Let's see if I can go ahead and just open it up so we can take a look at it. So I'm going to open it up in Vim. Okay. I maybe already have a Vim RC file on here. I don't see it. Maybe they actually updated some stuff in it. Okay, so this is one of my Vim RC files right here, kind of documented what I'm doing right here. And then I've got kind of my configurations taking place. I try to categorize them. Here's the color scheme right here, desert right here. That helps with some of the colors. And I'm just kind of going through the tab. Tab is a good thing to set up because by default, like when you try to indent your code on Vim, it's huge, it's massive. It'd be better to just do 4 spaces on that. So I encourage y'all to set up your own tab in there. This one right here, this is kind of showing you can go beyond, because I kind of have this Vim plug right here. This is a thing on GitHub. This is kind of Vim code right here. It has its own coding language where it imports the stuff from GitHub. Here's a curl kind of getting that information. And then these are some of the configurations to the plugin right here. So this is not even anything to do with Vim as far as, you know, who made this program. These are, you know, the community kind of adding to Vim. So you can expand this thing as far out as you want to. You can integrate it where you can browse your directories and everything with it. So really nice. So in order for the Vim to actually pick up, you need to have a Vim RC file inside your home directory. And so Vim knows to look for the .vim RC file. So it is a hidden file. So in this case, if I want it to read this, all I need to do, you will have to create yours from scratch. It's part of your homework. I just need to give it Vim RC and then just change it to .vim RC. So I just basically removing all this stuff off of there. So now when I open Vim, it should actually pick this up. So I'm going to, actually, I'll just open that same file back up here. So we'll do Vim. Actually, I can't do that. I renamed it. So vim.vimrc. Okay, so this is the GitHub stuff right here. It's let's see. It's already up to date. I can probably use Q to get out of it. Okay, so now you can see my color code has changed. I've got this nice, line numbers over here. I've also got it set up where it highlights the line that I'm in. It also underlines some things in here. And then I think I got mine set up, where I force it, where if I'm getting near the end of the line, but I'm not all the way at the bottom of the document, it keeps a padding right there. So when I get to the end, it'll finally actually scroll all the way down to there. So you can see that all the color codes have changed. You can't really see that my indents have changed. There is, let me see if I've got it in this one. Yes, this right here. So this is a fun little thing you can look up, that the fact that JK isn't something that ever happens together by it, or like by itself. So if you want to use JK because you'll never type it, then it will actually run the escape. So if you're sitting here typing, you can quickly do JK and it gets you out of command or insert mode back into command mode real quick without having to stretch your pinky finger all the way up to escape right there. So fun stuff. There's lots of things. I encourage y'all to kind of play with it. Let's take a look at your homework assignment real fast so I can show y'all what is needed out of that. Oop, wrong one. Here. Okay, the first homework assignment, it's pretty easy. I think it's only worth like 50 points. It is simply use TR. And because this used to not be in the same lecture as the Vim lecture, I just moved it recently. This is having you do the create submission. So you're literally just going in here. You'll do it on your machines. You'll do the create submission and then paste your commands from the command line in here. And like I said, it's just 3 of them. I just want the code that you use to get that. So make sure you grab everything, because if you don't grab it all, then in other words, I should be able to copy and paste this into my terminal. I'm probably not going to, but if I question it, I will copy and paste it. It should run. So everything you type in here, you should be able to copy it and then paste it back into your terminal and it should work. If it doesn't, then you're not going to get full credit on that. Let's see, when it comes to the other one, I wanted to point out one thing here. And so here I'm kind of giving you the format of a file right here. So note that the left and right arrows, those are placeholders. I want you to type your name. I don't want left arrow, your name, right arrow. It's just a placeholder. I think I even note that somewhere in here. So all of these, the arrows should go away. And then in order to complete this one, you're going to have to create your own .vimrc file. I give you a whole file right here that you can kind of play around with. These are some of the things I feel are the most important in here. And then you will, to answer this question right here, it's a compare and contrast of some of the options that are in here, 2 of the options, just to kind of prove to me that you played around with it. And then I give you on the submission, I'm wanting the actual document that you created. So this is just to prove that you can create a document in Vim, you can edit and format it properly. And then lastly, I'm wanting your vimrc file just so I can see that you did it as well. And so, and it looks like those formats are actually the same. Somebody tell me, what is this format right here? gzip. So do I use the tar command at all? No, perfect. It's just gzip, just so you're going to submit 2 compressed files, no archiving taking place in this whatsoever. Got that. Then also I got the cheat sheet for kind of Linux. It's just a few commands that are a list of commands we've seen so far, see them all in one place. But this one right here is the one that's the best right here. It has a nice breakdown of all those commands for you. Oops. All right. That is it. I think we're good to go. Make sure you check those due dates. I believe the due dates are Tuesday. What you got?
And Martin Tudor, the template assignment 1, what is that?
That was,
Oh, do I need to read?
still out there, right? Yeah.
Wait, take up
That would have been the last, I think it's, the quiz is that. We get the key in.
Oh.
Covers the permissions.
Okay.
No. It is the take home.
It is.
And the quiz.
Okay.